Hey folks, hopefully you can hear me. There's not a lot of wind today. What we're going to talk about is trusses. If you take a look at the side of this shed, you'll see we got a peak. The peak of this is called a gable end. So one of the first things you've got to decide when you're building trusses or building a roof is what the pitch is going to be. Now the pitch is expressed in, well, a ratio really, and what you can liken it to the way you can liken it to the way a set of stairs goes. For every so many inches up a step goes, there's the second number that's describing a set of stairs, the rise and the run, which is the how far back the stairs going to go. So the rise and the run is like 7 to 10, or whatever your stairs are going to be. When it comes to a roof, it's similar. It's how high up does your roof go for every 12 inches across. So you can see that if I rise up 1 inch, just estimate, if I rise up 1 inch for every 12 inches across, then you've got a very low pitch. If I rise up 4 inches for every 12 inches across, now we're starting to get a little bit more steep. And you remember that the steeper a roof, the easier it is for water and snow to melt and run off. You want that. A flat roof is a totally different situation. And when I was doing the blueprints for my shed, I looked online and it said if there's anything that's less than a 312 pitch, then you've got to take other things into consideration because it's too low. But it also had a lot of information about if it's greater than a 312 pitch, then there are certain considerations or certain things that you can do for internal bracing and structure of the truss itself. You can start changing certain things because the flatter it is like this versus how steep it is, it transfers the weight from the roof to the supporting structure in different ways. So when you start changing the slope, then you start changing how it's supposed to be made. So there's a lot of moving parts. So what I've got here is approximately a 30-degree pitch. So what that translates to is about a 712 pitch is how they'll explain it. So for every 7 inches up, I go over 12 inches. So that's the way my pitch is on this roof. Now, let's take a look inside at what I've done. These are very small sheds, so I didn't need to get a permit for them because they're so small, the forces aren't really going to push and pull at a very, hey, get out of there. No, get out, no. Sorry, he's a constant concern. The pitch is not going to be a big concern because of the size of it. The span across isn't that severe to warrant a lot of extra bracing and heavy consideration. The bigger you go, then it's starting to talk about, oh, we're spanning really far, so there'll be bends, so you got to make allowances for this, that, and the other thing. So let's take a look inside the shed in the trusses that I've got inside there, which were good enough, but they're not going to be good enough for the shop that I'm going to be building. Welcome to the shop. Hey, it's me again. All right, so what I've got is a view of the inside of the shed from the end. You see the triangular shape, the 712 pitch, and what it's consisting of. So what we've got is 2x4s that rest on top of the wall, as you can see. They just rest on top of the wall and they're toe-nailed in place. Now a different type of fastening system, not system, but a fastening technique is called a bird's mouth. So take a look to the right and you'll see a notation, sorry, not to the right, yeah, the right of your screen, and you'll see a notation in this Edpuzzle that shows you what a bird mouth is and how to perform that bird mouth, how to make sure that that piece of wood rests on top of the wall, how that truss, that rafter is what they're called when you stick frame, how it rests on top of the wall using a bird's mouth. But when it meets up at the top, you can see that the 2x4s just meet up at the top at the correct angle, and they're tied together with this piece of wood that goes across. Now I didn't have to put the angle on that cross piece, which is called a collar tie. All right, hopefully you can see this quite well. All those collar ties. That collar tie, it was interesting, and I learned something about collar ties versus what I thought I was putting up at the time, which was a rafter tie. Now a rafter tie would be a 2x4 that connects the bottom of the rafter here to the bottom of the rafter there. It's making the bottom part of the triangular shape of a truss. Now the collar ties, what they do is they stop the top of the roof from being ripped off. They actually hold the peak of the roof together. Now, if this was a larger structure, those two 2x4s could not meet like that. They would have to tie in to a board called a ridge board. Now, look again to the right, and you'll see a notation that indicates what a ridge board is and how it needs to be put in place and how big it's supposed to be. Technically, the ridge board has to be one size larger of nominal size from the 2x4. So if this is a 2x4, which it is, then that ridge board would have to have been a 2x6. So they put these rafter ties in because they're afraid of updraft. When the wind starts kicking up in the real world, it can literally create a vacuum and pull up your roof. These rafter ties hold the peak together. It's funny that that's a consideration that needs to be made, but it's very true. If you talk to your science teacher about the uplift of an airplane wing, you'll understand it a little bit more. But as wind blows across the roof, it creates a vacuum when it goes over the peak of the roof, and it literally has an uplifting quality or force. So those collar ties tie that together. I put them in place because I thought it would be fine to brace them from spreading to the left and the right. That is the purpose of a bottom rafter tie, which would tie the bottom third of those 2x4 rafters together. Now again, look to the bottom right and you'll see a picture and a little description of what a rafter tie is and its proper function. So, hello, welcome back. Now what we've got here is a very basic, very rudimentary picture of a cross-section of a shed. As you can tell, here's the walls on the left and right, and here's the rafters, and that rectangular piece up top is the center beam. So here's what we're going to talk about in this section. We're going to talk about where to put the collar ties and where to put the rafter ties in order to make sure this thing doesn't fall down. We're going to say that this structure right here, without putting in any measurements, this structure is big enough to require a permit and needs all that extra consideration that I spoke about just a minute or two ago. All that extra consideration to make sure that it stays strong and stable. So what we're doing here is not prefabbing all of our rafters or all of our trusses. What we're doing is we're building rafters in place. And the way that would work is you get a center beam and you put that in place and support it on the left and right, on the front and back end of the structure, supported up on top of the walls. And then you just start to, if you have a beam that runs this way like this, then you would put a rafter here, then you put a rafter on the other side, and just putting basically up to your 2x4s to meet the rafter at the right angle. So you'll have to cut the end of the 2x4 at the right angle to be fastened to the center beam, and a bird's mouth on the bottom so that it locks in place on the wall. That has a very interesting job to do, and that will be in the section immediately following this little discussion. So in order to make sure that, well, first off, the top of the roof doesn't come apart due to updraft from climate and weather and wind, what we do is we take a measurement from the top third of this entire triangle, and we can add a collar tie anywhere in the top third from the top of the wall to the peak. That is the area in which you can put a collar tie and have it actually do the job that it's planned to do, which is stop the roof from pulling apart at the peak. Now a rafter tie on the bottom, that's a collar tie. So that's in the top third. So a rafter tie goes in the bottom third, and it can go anywhere from the top of the wall, and you'll see sometimes people will build trusses and they'll place this bottom tangent, this bottom rafter tie that connects all the way across the bottom, and it sits on top of the wall. Now I've seen that. That's not a problem. But what we're going to do is we're going to place our rafter tie a little higher up. We can put our rafter tie to the exact same results anywhere in the bottom third. So I can put it at as low as the top of the wall or as high as 1/3 up. So I can put my rafter tie right up here. In fact, it doesn't have to be a cut on an angle. I would actually prefer it if it overlapped and fastened with screws, or sorry, with the proper nails, fastened with nails right there. Now what you can do is you can have a rafter tie in and cut it on an angle so this is smooth, but then you would have to put a piece of material right here, plywood, or a metal bracket that's called a gusset. Now a gusset is a rectangular piece of metal with a bunch of holes in it. I'll show you a picture on the right hand side of what a gusset is. That metal piece of material that spans across this joint would be nailed in place and would serve as a reinforcement for that joint. You'll look at pre-made trusses and they are just chock full of these gussets. So what we do is we are going to be placing our rafter tie at the top third. Now, can you think of any reason why we would place it at the top third as opposed to the bottom third? Because they serve the same purpose, they do the same job. I think that the number one reason, and this is the reason I am going with for why I'm going to put the rafter ties in my ceiling joist or ceiling rafters in the shop I'll be building as high as possible, is because I want headspace in my shop. So I just move up the ceiling. Now, what job does it do? It stops this left and right rafter from spreading apart. And can you remember what the force of the 4 forces that we talked about? What force does that rafter tie counteract? What is it actually securing against? The force that's being applied to that rafter tie is tension, because it's trying to be pulled apart to the left and right, stopping this wall and that wall from pushing aside. Like we talked about in our earlier presentation, if you had a square, it is very wobbly. As soon as you add a triangle, it stops it from spreading. If you push down on this top, the left and right side of these rafters will push out, and since they're connected to these walls, they will push the walls out. So the snow load will make the entire structure collapse. The rafter tie stops this from happening. Okay, now let's move on to bird's mouth. All right, now we're going to talk a little bit about the bird's mouth when we're tying things together. The bird's mouth notch that you cut into a piece of wood, this is a cross section of one intersection between a, I should write that in right there, between a rafter tie a rafter, the gusset that holds it together, and you'll see that that metal bracket that I indicated in that in that note, what that looks like and how that goes in place, and the rafter. Now this is a cross section of the wall, so this is a vertical wall coming up, 2x4 wall, and the rafter coming down has this notch cut out of it. Now the angle at which you cut that notch depends on the rise and the run or the pitch of your roof. And if you're cutting a bunch of rafters to go up onto a roof, the simplest method is to get the first one perfect and then just trace and cut. There is a whole field of study that we can go into and have an entire course on how to properly use a framing square. All the notations on this is a full course could be given on how to properly use this for setting up stairs and the rise and run of the stairs, and how to notch out your stringers, or how to cut the bird's mouth correctly on the rafters. The best way to do it for us is going to be just take it one step at a time, cut one, make sure it fits perfect, and then just trace for all the rest. The big part, you know what, I'll show you what we've got set up here for a demonstration. Let me move the camera back and we'll take a look. All right, now we've got our real live version. Small, but it's an accurate mock-up. What we've got are a couple of rafters that we had in our little diagram, but in real life. And I've notched out that bird mouth that I was telling you guys about. So we've got our 2x6, which is nominally one size of lumber larger than the rafters. So if this was a 2x6, this would have to be 2x8. As you can see, it's because it needs to be fully supported on the bottom of that ridge beam. Okay? If this was a 2x4, the 2x4 would come to here, and the bottom of the rafter would have no structural support. That's why it's got to be that much bigger. Because of the angle, it's a longer surface of the wood than 3.5 inches. So one size up is just fine. So this notch right here has to be calculated according to and paying attention to the rise in the run or the slope of your roof. We had a 712, so that worked out to I thought it was 30, but it was closer to 35 by the time I set my saw up. So I cut that with a little tape, with a little skill saw, and then finished it off with my lovely favorite little hand saw, my Dozuki saw. Anyway, so what we've got now is got the rafters. What you would do is, like I said before, you would support this ridge beam, level it, and put it in the right spot where it's going to go on the left, on the far ends of your roof. You would support it, and then you would start laying all of your rafters all along with the angles cut and the bird mouths cut, all patterned after your first piece, your pattern piece. So you cut your first one, make it perfect, notch it out, do the whole thing, and then you just lay it on top, cut it, cut it, cut it, and then you're just tracing and cutting, tracing and cutting. That's why the world has made us apprentices. That's what they would be doing. So here is what I've also got. I've got a left wall, and I've got a right wall. And what we've got here is our rafter system that doesn't go together and put in place first. It goes together one piece at a time. So these walls would be in place, boom, boom. You would structurally support, like I said, at the far end, a 2x6 ridge beam, and then you would start taking each rafter, putting one rafter up, the other rafter up, at the same location. You can't stagger them because they actually reinforce each other across the ridge beam. So the ridge beam is up, and then you put one rafter, 16 inches on center, next one, next one, next one. And here is, and you'll notice the double top plate of the top of our wall. So I've got some screws in place already, putting them in place, marking the top of your wall, of course, to ensure proper spacing here and along the ridge beam. They have to line up. They can't be on an angle. So what we'll do is we'll drive these screws in. One. And two. Now, you may be asking yourself, one screw to hold it in place? In real life, it won't be a screw. It will be a galvanized nail, an Ardox twisted nail. They don't spin out. They don't pull out. Once those Ardox go in, they stay in there. They're a nightmare to pull out. So the nail, much like we talked about earlier in another video, in order to counteract the four forces that are constantly trying to pull and push your structure apart, you need to place the wood in the right orientation. The fasteners, the nails aren't designed to stop the house from falling down. The nails and all of the mechanical fasteners are there to hold the wood in place so that their correct orientation and application will resist the forces trying to push and pull it. So the nail holds the wood from sliding back and forth. And the most you want that nail to do is be able to resist shearing apart. So if you got a nail, you don't want it to have so much force to snap the nail, allowing the wood to shift back and forth. So the nail is a placeholder. The wood is what resists the pushing and the pulling. So you can put as many nails as you want in. Say you have a structure that you're renovating, you're fixing up, and you see that, oh, there's a wall on the corner of my gazebo or shed that's falling apart. I should throw a few more nails in there. If you got a sagging roof, no amount of nails is going to fix that. It has to be the structural integrity of all the components working correctly in the right orientation. For instance, if I push down on this, okay, across this ridge beam, it's going to have this sagging effect if this ridge beam is not thick and wide enough. Remember, wider was better than thicker. So if this is not of the right dimensions, it's going to sag. You'll have a roof line that sags. Go, for a ride in the country, and you'll see some farms and some barns, and they've got this huge ridge line going all the way across their barn, and over the years it's sagged. Well, they've lasted a good number of years, but they don't have the right dimensions of lumber up there to support all of that weight, especially the long spans you see barns have. So this ridge beam has to be of the right dimension in order to resist the sag. These 2x4s can't span too far. If these walls were really far apart, you may have to bump these up to 2x6s, because the weight on this roof for a rafter would press down, and this 2x4 will only resist the bending pressure of a live load of snow and the dead load of the roofing shingles and the plywood to only such a distance. So once you go past a certain span, you got to bump up the size. And again, refer to the building manual, the building code, and it will tell you, well, how big of a piece of lumber do I need to span that far? So now to finish off with the bird's mouth, what we've got here is a rafter that goes all the way across. And what we would put in place at the end would be a rafter tie. So I'll put this in the back so we can see we can see what we're doing here. That'll just fasten to the back of these. At the bottom third, just like we talked about on my little drawing, this would be fastened across here, or you could cut it on an angle, fasten it in place with a gusset. But seeing as how where it's going to go, I think I'm just going to be doing a nice overlap of the wood, and then I drive nails in, maybe 4 nails each side. And again, those nails going in this way don't hold it together. All they do is hold the wood in place. They fasten the 2 pieces of wood together. The 4 galvanized Ardox nails of the correct size will resist being shorn apart. The outward pressure, as I press down on the roof, the outward pressure of the walls is trying to stretch this rafter tie apart, and it's fastened to the left and right side at the bottom of each rafter. If the nails are of too small a size or the wrong type, well, the shear force will break those nails and it'll just come apart. But if you have the correct nails, it will stop it from pulling apart. Now, let's talk, that's to hold the structure of the triangular rafter system, but it doesn't talk about stopping the walls from coming apart. Now, the bird's mouth is using the wood itself and the integrity of the fibers of the wood and how it goes together to resist the bending force. So this is pressing down and it's wanting to pull apart. This rafter tie is stopping it from being pulled apart, but at the same time, these walls need to be connected to the rafter system. The walls sit in this little notch, and if the wall wants to push this way, this little notch stops it from doing it. It sits in the pocket of the bird's mouth and holds it in place. So you can't go too deep here, but it just needs a little notch, just in order for the walls to have something to stop it. The nail that goes in here, just make sure that this rafter doesn't slide back and forth. It does not hold the wall up. The rafter, the ridge beam, the bird's mouth, the rafter tie, and if it was much, much bigger, you'd have a collar tie up here. That is all put that whole thing together, and the whole system working together. That's what keeps your structure from falling down. So every little piece counts, and understanding each piece counts in order to put it together in the right way. There's a story that I tell. There's a teacher that I know who has a gazebo, not a gazebo, he has a cottage in Port Stanley. And his carport was built by someone who had seen a rafter, had seen a truss, and built his structure, this carport, to look like it was done right. But if you really examine how all of his pieces went together, from the structural posts, the upright posts holding the roof together, and every little thing, you can tell that none of the components functioned, but they looked like they were supposed to be in the way that they were. It was really kind of scary. I've got some pictures that I should post. Anyway, that is basically how I'm going to be building the rafters for my shed. And this is one of the ways that you can build a roofing system for your house. The other way, and I'll post a little notation and a couple of links, where you can, well, call an engineering company and say, I need rafters to suit this purpose, this high, this pitch, and spanning this distance, and even describe in detail what the entire system is. And they will plug it into a computer, and their designers will go to work fabricating all your pieces, and they come as a solid unit. Now they can use 2x4s across the board, and you just put them up, and they all function perfectly because they're engineered that way. And all of the pieces that go into making up a single truss are in the perfect arrangement, in the perfect orientation to maximize the benefits of the integral properties of the lumber that it's made with. So I'll show you a couple of pictures of that as well. The last thing I forgot to say was, when you're manufacturing your rafters, you have to make sure that you actually cut this to a vertical angle. So if that was a 35-degree angle, this also has to be a parallel surface to that. And the reason is, when you finish your structure, you may want to have, well, you have to have something that connects the bottom, and they will go along this edge. Okay, we'll use this. Something that goes along the edge right here to connect the bottom of all these rafters, so that your sheeting comes down and has something to rest on, but also you have to have something that your eaves trough connects to. So that is another component to cutting your rafters.